Hey, hi guys, welcome to this video. In this video we are going to we are going to discuss this problem, palindromic substrings. Okay, now before we move forward, there are a couple of things you need to know. First, see, I do not only intend to discuss the problem, okay, but to maximize your learning using this problem. So first we are going to brute force the problem, then we will look at its time complexity. We will also be implementing the brute force approach, okay. After that we are going to look at the optimized approach of the problem and its time and space complexity. This is the first thing. Second, from today onwards, whatever problem I discuss, I am going to provide you implementation of those problems in Python as well as in Java also. Okay, so every problem will go like this. First we are going to discuss its approach, then we will implement its brute force solution in Python as well as in Java. Then we are going to discuss the optimized approach, and then we will be implementing optimized version in Python as well as in Java, correct? So let's say that if you are someone who codes in Python, so you look at the brute force approach explanation and then you jump to the timeline where I have discussed Python implementation. So you will find all of those timelines in the description, okay? So here for every video we have this description bit here, correct? So I will make sure that here I provide you the correct description so that you can jump to the Python implementation or Java implementation, whatever you wish for, correct? Now with that being said, let's move forward. You see, this is a very classical problem of dynamic programming. We will come to that later, okay? And even if you are someone who is just scared of dynamic programming, it's not something to be scared of, okay? By the time I end this video, I guarantee you are going to have fine idea about DP. We will talk about that later. So you see, problem is very simple. They are saying that you will be given a string and you will have to count how many palindromic substring exist, correct? In my previous video, I think I have already explained you what exactly a substring is. So again, quickly, substring is nothing but a continuous portion of a string, correct? So if I talk about a string, let's say ABC, okay, ABC, then what are the different substring? Of length 1 we have ABC, of length 2 we have AB, BC, of length 3 we have ABC, correct? How many substring we are going to have in total? Given a string of length n, you will be having n cross n plus 1 by 2 substring, these many substring, okay? In this case 6, so 3 into 4 by 2, in total we will be having 6 substring, and these are my 6 substring, correct? And you will have to tell me that out of all these substring, how many of them are palindrome, correct? For example, you look at this test case, triple A. So how many substrings triple A have? So of length 1 it has this 3 substring, of length 2 these 2. So first I will take this 2, then I will take this 2. Of length 3 we have a single substring, and all of them are palindrome, correct? Every substring that you see here are a palindrome, so that's why output is 6, correct? For example, for this ABC, look at this ABC, okay? So how many substring of length 1? 3, of length 2 2, of length 3 1, correct? Out of all these substring, only 3 of them are palindrome, which are these 3 substring, correct? So that's why output is 3. Now you think about it, one simple solution of this problem, you generate every substring. For every substring you check if that substring is a palindromic substring or not, and you keep on counting it. So first thing first, how we are going to generate every substring? In order to understand that, let's have a look at this particular string, madam. correct? So substring of length 1, m, a, d, a, and then m. Substring of length 2, m, a, d, d, a, am. Substring of length 3, m, a, d, a, d, a, d, a, m. Substring of length 4, m, a, d, a, then a, d, a, m. Substring of length 5, whole string itself. Okay, in total you will have 5 into 6 by 2, 15 substring. Count 5, 9, 12, 14 plus 1, 15, correct? So if I wish to generate every substring, I am going to approach this problem like this. So first thing that I will do, I will generate every substring of length 1. Then I will generate every substring of length 2. Then I will generate every substring of length 3, then length 4, and then length 5. Correct? So if I approach it like this, I will be able to generate every substring. Do you understand this or not? So given a string, I wish to generate every substring, and I am going to approach this problem that alright, I am going to generate substring length by length. Correct? So what is the minimum length a substring can have? 1. And what is the maximum length a substring can have? N. Okay. Is there any substring that is of length n plus 1? It's not possible. If I give you a string of length 5, the maximum length that your substring can have is 5 itself. Correct? So if I wish to generate every substring, we can target this problem length by length. And as I am explaining, let's keep on coding it also. It will not be difficult for you to understand. Please have a look here. So first thing that I will do, okay, since I wish to show you the solution in Java also, it's not better that I keep coding parallelly. Okay, we will code it later. Let's have a look here. So I am going to generate every substring of this string length by length. So here, please have a look and hold your breath. I am in no rush, and if you are willing to learn, you should also not be rushing. Okay, this is not something that you are just watching for the sake of completion. Please look here. So I am just going to run a loop from I equals to 1 to n. I will say, this is just pseudocode. Okay, I will say that when my I value is 1, I will try to generate every substring of length 1. When my I value is 2, then I will try to generate every substring of length 2. When my I value is 3, I will try to generate every substring of length 3, and so on so forth. Correct? Now this loop, it will run from I equals to 1 to n, and I will always try to generate substring of length I. Think about it. Let's say that if my I value is 3, so where is my first substring of length 3? Think about it. Is it not from index 0 to index I minus 1? In this case, from index 0 to index 2. You see MAD. This is first substring of length 3. Correct? You take any value of I. For example, if I take I equals to 4. So where is my first substring of length 4? It is from index 0 to index 3. Correct? Which is nothing but MAD. So what I will do, I am going to initialize two more variable, one with value 0 and another one with value I minus 1. Correct? If I put I equals to 1, then where is my first substring of length 1? 0 to 0, and so on so forth. Correct? Now let's try to dry run it for I equals to 3 only. Okay, here. So for I equals to 3, my j value will be 0 and k value will be 2. So if I use j as index on this string, I will be accessing first character, and if I use k, I will be accessing character at index 2. Okay, now this is my first substring of length 3. So let's quickly print it. I will print yes of 0 to 2. Just pseudocode, okay? Don't confuse it with any programming language syntax. It is just pseudocode. Read it that I am trying to print part of this string, and which part? From index 0 to index 2. Okay, now once I am done printing, where is my next substring of length 3? Think about it. It is from index 1 to index 3. So can I say that it is from index j plus 1 to index k plus 1? So after printing, I will move my j as well as I will move my k, both. Now again, where is your next substring of length 3? It is from index 2 to index 4. So when you have moved I and j for the very first time, now your I is here, j and k for the very first time, your j is here, k is here. I will print it again and I will move it again. So when I move it again, now my j will come here and k will come here. I will again print and I will again move my j and k. Till what point of time you will keep on doing this? Until your k crosses the boundary. See, if I move my j again, my j will come here, but k will go outside of a string index range. Okay, so can I not write the same thing programmatically, that as long as my k is strictly less than n? Okay, you keep on printing, not from 0 to 2, I will be printing from j to k. Okay, I will be printing from j to k. Okay, so can I not write the same thing like this, that as long as my k is strictly less than n, keep on printing the string in the range j to k and keep on moving j as well as k. Okay, so this is going to print every substring. First it is going to print substring of length 1, then length 2, then length 3, and so on so forth. I hope you understood this. So you see, we have solved one sub problem also. If someone comes to you and asks you that given a string, print all of its substring, can you code it now or not? Same goes with array also. If someone gives you an array and they ask you that for this particular array, print every sub array, this is the code. Okay, and I hope you understand this code now. Let's quickly code it. Okay, this is the pseudocode. Let's quickly code it now. So first I am going to show you the code in Python and then we will be coding it in Java. You will find the timeline for Python and Java code in the description, correct? So first thing that I will do, I am going to fetch the length of this string, and then I will just run a loop for I in a range of I wish to start from 1 and I wish to go till n. Okay, so that's why n plus 1. Now every time I will be initializing two variables, one with value 0, another one with value I minus 1. Why? Because again I will keep on try running it here itself. So let's take a string to be madam. So in this case my n is going to be how much? 5. So I will run for 1, 2, 3, 4 as well as 5. Let's consider about when I value is 3. So where is your first substring of length 3? It is from index 0 to index 2. So can I not say that it is from index 0 to index I minus 1? That's why I have initialized j with 0 and k with I minus 1, correct? After this, see, first thing that I will do is I am going to print this string from index I to index k. So I will write k plus 1 here. Okay, why k plus 1? Because slicing also goes from a start to end minus 1 in Python. So this particular slice, it is going to print a string from index I to index k only. And once I have it printed, where is my next substring of size I? It is nothing but from index j plus 1. It is present at from index j plus 1 to index k plus 1, correct? Earlier this is my j, this is my k. Now my next substring of size 3 is ADA. So after printing it, I will move my j, I will move my k. Until what point of time I will keep on moving these pointers? As long as as long as my k is strictly less than n. Okay, and all of these things we will have to fix the indentation. So this particular thing, this particular piece of code, it is going to print every substring for the given string. Correct? Let's quickly have a look if it is able to print it or not. So just to satisfy the syntax, I am going to write 0 here, return a 0, because this method, it needs to return an integer value. Correct? And let's run it. We will get incorrect output. We are not worried about that for now. Here, okay, it seems like we have made a mistake somewhere. Okay, there is something wrong in our code. So what is it we did wrong? Okay, we should be printing it from j to k plus 1, not from I to k plus 1. Okay, apologies, sorry. Let's quickly have a look now. Okay, see, now here the process that we wrote here, it is first printing, okay, it is first printing every substring of length 1, then length 2, and then length 3. Correct? Now that we are in the position to print every substring, we don't really need to print. We just need to check that if this substring that we are getting here, so let's store it inside this variable substr. We just need to check that if this substr is a palindromic a string or not. If it is yes, then I will keep on counting it. So I am going to have a variable count here, and in Python things are straightforward. Okay, this is how you can check if this substr is a palindrome or not. So if reverse of this particular thing, this string is same as the string itself, in that case you keep on increasing the count. Correct? Like this, and at the end of the day, instead of returning 0, I am going to return count. End of the story. This code, if I execute, it will produce correct output, and also in this case you are not going to get time limit exceeded error. I will show you. First, let's quickly discuss what is the time complexity of this particular approach. Correct? So here, think about it. How many substring you will be having? If I give you a string of length n, you will have n cross n plus 1 by 2. These many substring. Okay, and for every substring you are checking that if that particular substring is a palindromic substring or not. Here, look at this particular code. This is the same thing that I am doing. Now you see, I have seen a lot of people getting confused, and they will say that slicing is a constant time operation. It is not. Don't stay under false impression. Okay, you think about it. What does slice do? Here in this case, what this slicing is doing, it is reversing whole string. And if you come to me and you tell me that sir, it is a constant time operation, does it make sense to you? It's just not possible to be done in constant time. If I give you a string of length 10, and let's say that if you are taking 1 second to reverse it, will you still be taking 1 second if I give you a string of length 10 crore? Of course not. So this is not a constant time operation. Okay, it is order of n operation. If this slicing length is n, then it is going to take order of n. First time your slicing length will be 1, then 2, then 3. So it's safe to assume that in worst case you will be consuming order of n time here also. Not for every string, but then it's okay. It's nothing less than a cubic solution. Okay, so order of nq is the time complexity for this particular approach. Now if I submit it, you will see that it will get accepted, and the reason lies in the constraint. I will show you. Please have a look. You see, the solution got accepted. Even NQ solution got accepted. Why? Because if you pay attention to the constraint, they have clearly told you that they are not going to give you a string more than 1000 in length. So in the worst case, this is the maximum operation that you will be performing. 10 raised to power 3 ka cube. So 10 raised to power 9. If within 1 second 10 raised to power 9 operations are allowed. Okay, now if I wish to code the same thing in Java, okay, if I wish to code the same thing in Java, so how we are going to do it? Very easy. Please have a look. Here, first thing that I will do, I am going to evaluate length of this string. Okay, length of this particular string, and then I will run a loop from 1 till I less or equals to n. Okay, here I will say that when my I value is 1, then I am going to print every substring of length 1. When my I value is 2, then every substring of length 2, and so on so forth. Now same story, I am going to initialize two variables, one with value 0, another one with value I minus 1, and then as long as my k is strictly less than n, first thing that I will do, I will print the substring from index j to index k. So here I am just going to create another string here. Let's name it substr, and yes dot, if you wish to fetch substring of a string, I think there is a method substring itself in Java. Okay, so I am going to invoke this method from index from index j to index k. So I need to write k plus 1 here. Okay, and then let's just print this particular string substr. Correct? And every time I print it, I am going to move my j, I am also going to move my k. And just to satisfy the syntax, for now let's write 0 here, return the 0, and see if we are able to print every substring or not. So if I run this particular code here, please have a look. We are able to print every substring. So first it is printing substring of length 1, then length 2, and then length 3. Now if I wish to check that if this substring is a palindromic substring or not, so how we can do it in Java? Please have a look. There are multiple ways you can do, but then look here. Let's say that if I wish to check if this string is a palindromic string or not. So you see, we are solving one more problem here. I told you in the very beginning that agenda of this video is not just to solve the problem that I have presented, but to maximize your learning. Now if I wish to check that if this string is a palindromic string or not, then how we can do it? Very easy. I will initialize two pointers, one at the start, another one at the end. If the characters are same, then I will move I in that direction and I will move j in this direction. Again characters are same, move I in this direction, move j in this direction. The moment my I either becomes same as j or it crosses j, I will stop at that point of time and I will return the true. Okay, but if I find any mismatch, for example, you look at this string. You look at this string, initialize a pointer here, another pointer here, characters are same, move I. Again characters are same, move both of your pointer. Now you see at this point of time I will find a mismatch, so I am going to return false. But then let's say that I kept on moving I and j and I never found any mismatch. So in that case I will return true if my I becomes same as j or if it crosses j. Okay, so let's quickly do that. What I will do, I am going to write one more method here. Let's have a private method. It is going to return you a boolean variable, and let's name this method is palindrome. Correct? So this method, it is going to receive a string, and job of this method is to return true or false. If the given string is a palindromic string, then return true, otherwise return false. So I am going to initialize one pointer at the start and another pointer at the end of the string. Correct? So what is my last index? Length minus 1. And now while my I is strictly less than j, correct? First thing that I will do, if my str dot char at I, if my str dot char at I is not same as str dot char at j, so character that is present at index I, if it is not same as character that is present at index j, then immediately return false. Okay, but then if they are same, then move forward and check the next character. Let's say that control comes outside of this while loop. In that case you return true, correct? In that case you return true. Do you understand this code or not? It's very simple. Okay, so here I will keep on matching character at index I and j. At any point of time, if I find any mismatch, I will return false immediately. If I do not find any mismatch, I will move to the next comparison. And if control comes outside of this while loop, if control comes at line number 24, what it means? That this return never gets executed. So if the answer is not false, then it is true. Now here I wish to check, again I will do the same thing here also. In order to store my answer, I am going to have a count variable that I will initialize with 0, and then I wish to check if this particular string substr is a palindrome or not. Okay, so here answer equals to, I am going to invoke this method is palindrome of this particular substr. If my answer is true, okay, in that case I will keep on increasing my count, and at the end of the day, instead of returning 0, I am going to return count, correct? See, when you are watching this video, please do not try to note the code or anything like that. I will give you code in this particular repository. I have created it just now. Now if I execute this file, I should get correct output. If I don't get, then we will see what went wrong. Okay, and now if I submit, it should get accepted. Correct? So this is the brute force solution. Again, what's the time complexity of this particular solution? It's nothing but NQ. You think about it. Here you will get to see it clearly. This loop will run exactly how many times? N time. Every time this will also run close to n time. Okay, and then every time this is also going to consume order of, this is also going to consume order, actually not order of n every time, but it is close. Okay, because you see this particular loop, it will not run n time, it is going to run n minus I will tell you I minus 1 these many times. Why? Because there are exactly these many substring of length I. Think about it. If I put I equal n minus I plus 1, if I put I equals to 1, then this will become n minus 1 plus 1, which is nothing but n. So there are exactly n substring of length 1. If I put I equals to n, then n minus n plus 1, there are exactly one substring of length n. Okay, so it's not exactly nq, but it is also nothing less than cubic solution. Okay, now here, once you have understood the brute force approach, let's move forward and try to think how can you solve this particular code in less than nq. Okay, in less than nq. So in order to understand that, let's take this particular string Malayalam. Okay, Malayalam. Here, see, first thing that I will do, I am going to maintain a two-dimensional array of dimension n cross n. Okay, n cross n. So in this case, my n length is 3, 3, 6, 3, 9. So I am going to create a two-dimensional array of dimension 9 cross 9. Let's quickly do that. Okay, again, when I am solving it on pen and paper, you shouldn't be bothering about the code. Okay, forget about the code. How we are going to implement it programmatically, I will take care of it later. 4, 5, 6, 7, 8 and 9. Okay, so here 0, 1, 2, 3, 4, 5, 6, 7, 8, and we will be having 9 columns also. 1, 2, 3, 4, 5, 6, 7, and 8. So 0, 1, 2, 3, 4, 5, 6. Okay, we are one column short. 7, 8. Okay, we are going to maintain a two-dimensional array of dimension n cross n. Okay, next thing that we will do is we are going to give a logical meaning to this particular two-dimensional array. See, there are always two steps of DP that you will have to follow. Okay, what exactly DP is? Dynamic programming. I mean, that's a very vague definition. What DP means to do is remember your past, correct? So whenever you will be having repetitive work that needs to be done again and again and again, you shouldn't do it. You see, there's a very famous quote that says, one who do not remember their past are condemned to repeat it. So where, let's say that if I come to you and I ask you to perform some mathematical equation every now and then, so you can just do it one time, remember the result, and when someone asks you to do it again, you just give them the same result. You don't really need to repeat the process again and again. This is one thing. Second thing, whenever your next solution is dependent on previous solution, you see, in this case also we would like to remember our previous solution. We will talk about it. All these technicalities, even if you do not understand and you do understand the process, then you are good. Okay, or please let me know in comment. I will create a whole video of 3-4 hours on dynamic programming. Okay, for now, see, the logical meaning that we will give here to the grid is this. You pick any cell. For example, let's say that if I pick this particular cell, so this cell is present at row number 1 and column number what? 6, correct? So I am going to say that this cell will represent the substring from index 1 to index 6. Okay, in this case from A till L, and this cell will store 1 if substring from index 1 to 6 is a palindrome, otherwise it is going to store 0. Okay, similarly if I pick, let's say, this cell, so this cell is present at row number 4 and column number 5, so I will say that this cell is going to store 1 if substring from index 4 to 5 is a palindrome, otherwise though by default we have 0 here, I will let it be 0, correct? Does it make sense? I hope it does make sense to you. So what is it we are going to do here? In all of these cells of this particular DP, of this particular two-dimensional array, I will be storing either 1 or 0. Okay, when we will be storing 1? When substring from row number to column number is going to be a palindrome. I will repeat it again. If I pick this particular cell, this cell is present at row number 0, column number 7. So if this substring here, if this particular substring from index 0 to index 7, 4, 5, 6, 7, if it happens to be a palindrome, then I will be storing 1 here, otherwise I will store 0. Okay, so I hope it does make sense to you what is it I am going to try to store in this particular grid, correct? Now that you have understood, let's look at one more thing. You see, the moment you gave it a meaning like this, every cell that is below this diagonal is meaningless for you. Do you see this or not? Now here we will learn one more thing. So you see, I told you, single question, multiple learning. Okay, maximized learning. I will tell you what is it we are going to learn sometime later. So any cell that is present below this diagonal is actually meaningless for you. Think about it. Why? You have time till I fill up 0. So when you will create this two-dimensional array, by default I will populate it with 0. Okay, everywhere. Please think why these cells are meaningless. You pick any cell in this region, lower triangular. Okay, for example, if I pick this cell, so this cell is present at row number 4 and column number 1. This cell is telling you that I am going to represent answer for substring this by ALA. By ALA, it is not even a valid substring of the given string. ALA by, this is a substring. Substring do not go from right to left, okay, it only goes from left to right, correct? So if I talk about cat, CA is a substring, AC is not a substring, so any cell that is below this diagonal is meaningless for you, correct? So we are not going to touch these cells. When I will be parsing this matrix programmatically, there also I will parse it diagonally itself, okay? We are not even going to touch these cells, correct? So you see one more learning, given a two-dimensional matrix, parse that matrix diagonally, correct? We will come to that later. Now think about what this diagonal is representing. This diagonal is representing substring of length 1. Do you think do you see this or not? Why? Pick any cell on this diagonal. So this cell, it is present at row number 2, column number 2. So from 2 to 2, it is talking about this substring. Then let's talk about this row number 5, column number 5. From 5 to 5, it is talking about this substring. So every substring of length 1 is always going to be a palindrome, correct? So let's put 1 on this particular diagonal blindly. You don't need to do anything here, okay? Now what is the next diagonal representing? Next diagonal is representing substring of length 2, correct? Substring of length 2, and then next to next substring of length 3. You pick any cell on second diagonal. So this cell, it is present at row number 2, column number 3. So 2 to 3, I am talking about this particular substring. This is 2 in length. You pick any cell on third diagonal. Let's pick this cell. So this cell is present at row number 3, column number 5. So 3 to 5, I am talking about this substring. So this is 3 in length. So for length 2 and length 3 substring, you don't really need to do any work. Your answer depend on first and last character only. If first and last characters are same, then it is going to be a palindrome, otherwise it will never be a palindrome. Do you understand this or not? I will repeat my statement again. For length 2 and length 3, if my first and last characters are same, then I will say that the string is a palindromic string, otherwise it cannot be a palindromic string, correct? For example, you look at this now, AXA, does it even matter what I put in between? You can put anything in between, it is always going to be a palindrome, correct? But if I talk about this AXB, you put anything in between, it can never be a palindrome. Same goes with two character string. So if I talk about AA, it is a palindrome because both of the characters are same, correct? So for length 2 and length 3, your answer depends on first and last character only. So let's quickly build these two diagonal here. Are the characters same? No. 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 And again here 7 and 8. Are the characters same? No. Correct? So you see on second diagonal everywhere you have 0. What does it represent? That there are 0 substring of length 2 which is a palindrome, and that you can clearly see here. Correct? Now let's move to the next diagonal. Here are the characters same? Character at index 0, is it same as this particular character? Character at what index? Index 2. Okay, let me write the indexing also quickly. Here, are the characters same? No. Are the characters same? Yes. You see, character at index 1 is same as character at index 3. So no matter what is present at index 2, 1, 2, 3 is always going to be a palindrome. Correct? So I will put 1 here. Now, are the characters same? No. Are the characters same? Yes. Again, character at index 3 is same as character at index 5. Please have a look. So 3 to 5 is always going to be a palindrome. Now, are the characters same? No. Are the characters same? Yes. Are the characters same? No. Okay. So to build the answer, to write the answer for first, second and third diagonal, it is a straightforward process. Now, what will you do from fourth diagonal onwards? So that is also very easy. Okay. See, this is what I was talking about. My answer will be dependent on the previous diagonal. Now if I talk about this particular string, madam, okay, can I say that this string is a palindromic string because it is satisfying two criteria. First is, first character is same as last character, and next criteria, in between we do have a palindrome. Correct? If any of these criteria gets violated, any of these things gets violated, it can never be a palindrome. So for a string that happens to be more than 3 in length, if it is a palindrome, then I can say that there are two conditions that must have been satisfied. First character should be same as last character, and second, in between substring we should have a palindrome. Correct? So keep this thing in your mind and look here. Are the characters same? Character at index 0, is it same as character at index 3? No. Then we don't even need to look what is present in between. If first and last character itself is not same, then put 0. Are the characters same? No. 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 So what it meant to say that there are no substring of length 4 that happens to be a palindrome. Let's move forward. Are the characters same? No. Are the characters same? Yes. You see, character at index 1 is same as character at index 5. Okay, pay attention to this particular string. Character at index 1 is same as character at index 5, and both are A. So can I immediately say that from index 1 to 5 we have a palindrome? No. Now you need to look in between. Two criteria needs to be satisfied. First character needs to be same as last character, and in between wala substring we should have a palindrome. So what is present in between? 2 to 4. Index 2 to 4. So now I need to know that is my substring from index 2 to 4 is a palindrome. Okay, and where is the answer for that present? Look one diagonal back. Look one diagonal back. Okay, you see this cell is storing the result from index 2 to index 4 only, and it is saying 0. So even if my character at index 1 and 5 are same, in between we do not have a palindrome. Correct? So I will put 1 here. Let's move forward. Are the characters same? Yes. So again, character at index 2 is same as character at index 6. So can I immediately say that 2 to 6 is a palindrome? No. We need to look in between. What is in between? 3 to 5. Where is the answer for 3 to 5 present? Look one diagonal back. Okay, and it is saying 1. So 3 to 5 is a palindrome. That's why substring from index 2 to 6 is also going to be a palindrome, and I will put 1 here. Move forward. Are the characters same? Yes, characters are same, but one diagonal back we have 0. So I will put 0 here. Move forward. Characters itself are not same. Now move forward. Are the characters same? No. 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 Again, are the characters same? No. Are the characters same? Yes. So character at index 1 is same as character at index 7. So now we will look in between. What is in between? 2 to 6. Where is the result for 2 to 6? One diagonal back. Okay. So it is saying 1. That's why we will place 1 here. Again, move forward. Are the characters same? No. Are the characters same? No. Are the characters same? No. Are the characters same? Yes. So now the characters are same. We will look one diagonal back, and it is saying 1. That's why we will place 1 here. Okay. See this grid. It can answer multiple questions. Total number of palindromic substring. How many times you wrote 1 in this grid? You don't even need to parse this grid separately. When you were writing 1, at that point of time itself you could have kept on counting. Okay, every time you write 1, you increase a count variable, count plus equals to 1, and so on and so forth. There are couple of more questions that this particular grid can answer. Okay, if someone asks you largest palindromic substring, okay, so you see When was the last time you wrote one? A smallest palindromic substring which is not 1 in length. When was the first time you wrote one and you were not present on first diagonal? If you are actually, first diagonal is representing substring of length 1 and every substring of length 1 is a palindrome. So if I ask you a smallest palindromic substring, any single character is a valid answer. Correct? Any single character is a valid answer. But then that's not the question. The question is a smallest palindromic substring which is not 1 in length. So when was the first time you wrote 1 and you were not present on your first diagonal? Okay, you will get conflict. You see, there are multiple answers for that question. A smallest palindromic substring which is not 1 in length. We have ALA, then we have A by A, and then ALA. So there are two such answers, ALA and A by A. Correct? But then if we have conflict, then we have it. Let it be. What difference does it make? Now, what is the total time complexity of this particular approach? Order of n square. That's it. It's not even n square. It is much less than n square. It is n square by 2. Okay. We will never going to even touch these cells. I am going to parse this matrix diagonally starting from this diagonal. So we will first parse first diagonal, then we will move to the second diagonal, then to the third diagonal, and so on so forth. Correct? We are not even going to touch all of these cells. Okay. So but then you can say that it is quadratic in solution, order of n square. Do you understand this or not? Now that if you have it understood, let's quickly go and try to implement it. Correct? So you see, in order to implement this particular approach, you need to solve another sub problem. That is nothing but how can I parse this matrix diagonally. So let's quickly have a look at that first. Here, if I talk about this particular matrix, let's say that it is of dimension 4 cross 4. Okay, and I want to parse this matrix diagonally starting from this diagonal. So let's do some observation. This diagonal, it is starting at index 0 and at row number 0, column number 0, and it is ending at row number 3, column number 3. Now next diagonal is this one. So this diagonal, it is starting at row number 0, column number 1, and ending at row number 2, column number 3. Now this diagonal, it is starting at row number 0, column number 2, and ending at row number 1, column number 3. This diagonal, it is starting at row number 0 and column number 3, and it is ending at row number 0, column number 3. Correct? So can I say this or not, that every diagonal, here please have a look, every diagonal will start at row number 0. First thing, in total how many diagonal do you have? You have exactly n diagonal. Correct? You have exactly n diagonal. So first diagonal, it is starting at 0 0, and for the next diagonal, row number will come back to 0, but column number will go previous column plus 1. Again you see, for the next diagonal, row number will set back to 0, but column number will go to 2. And for the next diagonal, again if you pay attention, row number will set to 0 and column number will go to 3. So I am going to initialize a value call with a variable call with value 0, and I will say that as long as my call is strictly less than n, I have a diagonal that needs to be printed. In this case, my n value is 4. Correct? So here call will run for 0 1 2 3. When my column value is 0, I will initialize another variable row with value 0 every time. Think about it. I will do something here, and at the end of the day I will move my column by 1. Correct? So when your column value is 0, you will be picking up pairing row 0, and I am going to use a column flag that will be initialized with call only. Okay, so look at this pair. Initially it will be 0 0. Why? Because your call value is 0. Let's write it properly. Okay, let's just name it call flag here. So initially row and call flag will be 0 0, and then my column will change to 1. so it will become 0 1, this diagonal. See, this diagonal is just starting from 0 1. Then my call will become 2, so this pair will be 0 2. So you see this diagonal is just starting at 0 2. Then your call will become 3 0 3, and then your call will become 4, and this while loop will get terminated. Okay, so now I have a starting point of a diagonal. Let's talk about any diagonal. Let's say that let's consider the scenario where your call flag is 1 and row will be 0. Okay, so I am talking about this diagonal. Now I want to parse this particular diagonal. Okay, and in this direction we will have to parse. How we are going to work on this particular diagonal? Very easy. You see, if this is 0 1, then this is 1 2, and this is 2 3. Okay, so my next cell on this diagonal is present at index row plus 1, column flag plus 1. Do you see this or not? Okay, and till what point of time I will keep on working? If you pay attention, you will realize that every column is ending at every diagonal is ending at column n minus 1. So can I not write the same thing like this, that while my call flag is strictly less than n, I will print my matrix of row and call flag, and then I am going to move my row plus equals to 1 as well as call flag plus equals to 1. Okay, think about this. First, my row is 0, call flag is 0. Call flag is 1 in the case of this diagonal. So I will print this cell. Okay, and then my row will become 1, call flag will become 2. I will print this cell. Then my row will become 2, call flag will become 3. I will print this cell. And then my call flag will become 4. So this while loop will terminate. Correct? So this piece of code, it is going to print a two-dimensional matrix diagonally, starting from the middle diagonal and only going to the upper triangle. Correct? We have never even touched these cells. Please have a look. I am going to code this particular thing first, and then we will talk about how we can incorporate changes to code this particular approach. Okay, let's quickly have a look. So now let's first do it in Python. Here I am going to fetch the let's just have an array. Let's name it dp, and let's have an array of dimension 4 cross 4. Let's have this array 3 8 1 2 9 minus 1 3 9 1 3 2 5 6 0 8 minus 1 7. Array, yeah, this is too much. Okay, let's take an array of dimension 3 cross 3 only. 2 1 5 6 8 9. Let's take this particular array. Okay, so here we have 3 8 1 in my first row, then in my second row we have 2 1 5, and then in my third row we have 6 8 9. Correct? Now here I am going to fetch length of this particular dp array. Okay, this is going to be a square matrix, so you don't really need to be worried about length of row and length of column. They are going to be same. Okay, and now here I am going to have a variable call that will be initialized with 0, and then I will say that as long as my call is strictly less than n, I have a diagonal that needs to be printed. Every diagonal will start at row number 0, and let's have another value call flag that will be initialized with call. Okay, with call, and then as long as my call flag is strictly less than n, I will say that I have a available cell on my current diagonal. Correct? So I am going to print dp of row and call flag, and I am going to move my row number as well as my column number. And now here when I comes outside of this while loop, I will move my call. Okay, and just to satisfy the syntax, let's return a 0 for now. Here also I am going to print everything in a single line, so let's just write int equals to this. Now if I execute this code, you see output that I am expecting is this 31985. okay, and after that 1. Let's quickly have a look. here please have a look. 319851, correct? Now let's move forward and code this particular thing in order to find out total number of palindromic substring. You see here, step number 1, we are going to maintain a two-dimensional array of dimension n cross n. So this DP array that I have hard coded here, I am not going to hard code it like this. Instead we will be creating this DP array, and it is going to be filled up with 0 I in range of n, and it is going to be n cross n in dimension, correct? And then 4j in range of n. Okay, and now here this is the place where I am having access of this particular array diagonal by diagonal, starting from first diagonal, correct? So instead of printing the element, I need to populate the array element. Okay, I need to build my DP array. Now how we will be building? First case, if I am on my first diagonal, then by default I will place 0, because you see, sorry, 1. First diagonal represent a substring of length 1, and substring of length 1 is always going to be a palindrome, correct? How we will identify that if I am at my first diagonal? Very easy. When my row number is same as my column number, you pick any cell on your first diagonal. So this cell, it is present at index 3 3, row number 3, column number 3. So here can I not say it like this, that if my row value is same as call flag, then I am present on my first diagonal, correct? So in this case, in my DP of row and call flag, I will put 1, and every time I put 1, I am also going to move my count. Now this count is going to be a variable that will be initialized with 0, and at the end of the day, instead of returning 0, I am going to return count, correct? Now see, this is about first diagonal. Now if let's talk about second and third diagonal. You see, for second diagonal, difference of column and row is 1. Do you see this or not? You pick any cell on the second diagonal. So if I pick this cell is present at column number 2 and row number 1. This cell is present at column number 5, row number 4. So for the second diagonal, your difference of column and row is 1, and for the third diagonal, your difference of column and row is 2, correct? Pick any cell on the third diagonal. So this cell is present at row number 3, column number 3 and row number 1, correct? So in this case, my difference of column and row is 2. So can I not write this thing like this programmatically, that if call flag minus row is less or equals to 2, so in this case it will be either 2 or 1. So in this case, I just need to check first and last character. If my first and last character are same, then from index row to index call flag, my substring is going to be a palindrome, correct? Here, look at this particular case. Here we have 1. So my first character is present at index row, and my last character is present at index call flag. So if these characters are same, then in my DP array I will place 1. So can I not write it like this, that if my yes of row is same as yes of call flag, okay, if the characters are same, then in your DP of row and call flag, place 1. And whenever I place 1, I will keep on moving my count also, okay? Now my last else. So my first if is dealing with first diagonal, this if is dealing with either second or third diagonal, and then this else will deal with rest other diagonals, okay? So 4th, 5th, 6th and so on and so forth. Now from now onwards, we need to check two things. First, characters needs to be same. So character that is present at first index, that is nothing but row, and last index, that is nothing but call flag. See, if I am talking about a cell that is present at index row and row number row and column number call flag, then I am also talking about the same substring from same index to same index, from index row to index call flag. That's why this is my, okay, it should be like this. This is my first character. Okay, yes of row is my first character and yes of call flag is my last character. If they are same, then can I immediately write something like this, that dp of row and call flag, please put 1, and every time I put 1 I will also be moving count. If I write it like this, it is incorrect, because for length 4, 5, 6 and onwards you need to check two things. First character needs to be same as last character and in between we should have a palindrome, correct? So where do we have in between? Let's talk about this cell. So this cell is present at row number 1 and column number 7. Where is in between? You see, next row and previous column. If this value is 1 in my DP array, if next row previous column is 1, then only I will be putting 1. So here you need to have one more condition, and my DP of next row, so row plus 1 and previous column, okay, call flag minus 1. If this value is 1, in this case place 1 in the DP array and count it, okay? And at the end of the day, all we have to do is we will have to return this count. Okay, what is the total time complexity of this approach? Order of n squared. And if we hadn't made any mistake, it should work. Let's quickly run it. अरे यार, इसको क्या तकलीफ है? Cannot access local variable dp. Oh, sorry, this should be present here. This length is going to be length of your string. Actually we are going to maintain a dp of dimension n cross n, where n happens to be length of your string. Okay, and now let's get it submitted. Correct, it got accepted. Now the next thing, I am going to provide you solution for this particular approach in Java also. So let's quickly code it. Keep things in your mind, the process in your mind, and code it. First thing that I will do here, please have a look. Let's reset it. This was our brute force approach. Okay, first thing that I will do, I am going to figure out length of this particular string. And after that I am going to create a two-dimensional array. Let's name it dp of dimension n cross n. Correct? Now here, next thing that I will do, I will parse this dp array diagonally, starting from first diagonal. Okay, so this approach that we have used here I am going to code the same approach. So I will be having, please have a look, I will be having a variable call that will be initialized with 0, and then I will say that as long as my call is strictly less than n, I have some diagonal that needs to be printed, and every diagonal will start at row number 0 and column number call. Okay, so column number I am storing in call flag variable, and then as long as my call flag is strictly less than n, what I will do, I will say that I have a diagonal, like I have a cell on my current diagonal, correct? So I will do something with that particular cell, and I will move my row number, I will move my call flag number, correct, like this. Okay, and then what is it I will do? I will populate my dp array. I will populate my dp array, and in order to populate my dp array, think about your three scenarios. Okay, when you are present at your first diagonal, okay, you are always going to write 1. So how we will identify if I am at my first diagonal? Here, how we will identify if I am present at my first diagonal? Correct, it's very easy. On your first diagonal, difference of your column and row is 0. Okay, it is 0. Do you see this or not? On your first diagonal, pick any cell on your first diagonal. So difference of your column number and row number will be 0. Okay, so can I not write like this, that if my call flag minus row is 0, okay, in this case in my DP of row and call flag I will blindly put 1, and every time I put 1 I am also going to count it. Okay, this count variable you will have to create it. So let's create it here, int count equals to 0. Okay, now how I am going to identify next thing. Okay, so when you are on your first diagonal you will always place 1 blindly. When you are on your second or third diagonal, here second or third diagonal your answer only depends on first and last character, correct? So how we will identify if we are at our second or third diagonal? You see, for your second diagonal difference of column and row is 1, and for your third diagonal difference of column and row is 2. You pick any cell. So if I pick this cell on my second diagonal, so it is present at column number 2, row number 1, correct? So what is the difference of column and row? 1. If I pick any cell on my third diagonal, let's pick this cell. So this cell is present at column number 2, row number 0. What is the difference between column and row? 2. So here, can I not write like this, that else if my call flag minus row is less or equals to 2. So it will either be 1 or it will be 2. So I am present on either second diagonal or on third diagonal. Okay, and in both of the cases all you have to do is you will have to check first and last character, correct? Where is your first character? First character is present at index row and last character is present at index call flag. I told you now, if I talk about a cell here, if I talk about any cell, so let's talk about this cell. This cell is representing a substring from index row number to index column number. So first character for that substring is present at index row number only, and last character is present at index column number only here. So can I write it like this, that if yes dot char at row, if this character is same as yes dot char at call flag. Okay, in this case in my DP of row and call flag put 1. Okay, and please count it. Every time you put 1 in your DP array, also count it, correct? And now my last else. So if I am neither at my first diagonal nor at my second diagonal nor at my third diagonal, then I will be either at 4th, 5th, 6th and so on so forth. And in all these cases there are 2 conditions that needs to be satisfied. First character should be same as last character. Okay, here first character should be same as last character, and see, if when my first character is same as last character, after that I will look 1 diagonal back to see what is present here. Because you see, for any string more than 3 in length, 2 condition needs to be satisfied. First character needs to be same as last, and in between we should have a palindrome, correct? So where is the result for in between present? If I talk about this cell is present at row number 1 and column number 7, correct? This cell. So what is in between? In between is nothing but 2 to 6, next row, previous column. So can I say that if my DP of row plus 1 and column minus 1, so here and DP of row plus 1 and call flag minus 1, if this value is 1, in that case in my DP of row and call flag please put 1, and every time you put 1 you also keep on counting it. Okay, and at the end of the day all we will have to do is we will have to return this count. So let's quickly do that. If we hadn't made any mistake, it will work. If we haven't made any mistake, okay, I don't care about it. Time limit exceeded. What is it we did? Okay, we have forgot to move our column value. Okay, so once I am here, please have a look here. Once I am done doing work for my first column, now we should go to our next column. So this call variable needs to move. Okay, so let's quickly do it. Let's run it and now submit it. Okay, so it got accepted. Now thank you for being here, guys. Now before I end this video, you see, using this problem itself we have learned so many things. We have learned how you can check if a given string is a palindromic string or not. Then we have also learned, given a two-dimensional array, can you parse that array diagonal wise itself or not, okay, starting from middle diagonal and only going up. Then we have also solved this particular problem. Do you want me to solve something more here? Let's quickly do it. So suppose, think about it, if someone asks you that from this string can you please give me largest palindromic substring, okay, largest palindromic substring, then how can you do it? And then if someone asks you that please give me a smallest palindromic substring which is not 1 in length, okay, let's quickly approach this problem one by one. So first thing that I will do, I am going to maintain another variable, largest palindromic sorry, let's just give it a name, largest, okay, it is going to store largest palindromic substring itself. Now you see, since we are building this matrix length by length, diagonal by diagonal, so first diagonal will be corresponds to a strings of length 1, second diagonal will be correspond to a string of length 2, and so on so forth. So can I not keep on updating my string, my largest string here, largest string, every time I get a palindrome, so it will get updated last time also. If I keep updating this largest string every time I get a palindrome, okay, so how we will identify in this program where I am getting a palindrome? Whenever you are writing 1 in your DP array, so from index row to index call flag, that substring is a palindrome here. So yes dot substring of from index row to index call flag plus 1, I wish to go till call flag, okay. Every time I write 1 in my DP array, I will keep on updating my largest string also. So if I keep on updating it every time, it will get updated last time also, okay. So last time, it is for obvious reasons, last time we are going to deal with the last length itself. So here if I do system.out.println, you see it is going to print largest palindromic substring. Let's quickly have a look. Here there is a typo, okay, it is largest. Here see, largest palindromic string is C. We have more than one largest. A is also largest, B is also largest, but then we are getting largest palindromic substring here, triple A. If I run it on some other test case, let's say Malayalam, so I know for a fact that for Malayalam largest palindromic substring is whole string itself. Here please have a look. If I remove this yum from here, okay, so from this particular test case, okay, here from this particular test case, if I remove yum, then my largest palindromic substring is this, ALA by ALA. Let's quickly check that if I am getting it or not. See, so now you see, single question and so much of learning, correct. Now if you think that I was able to help you, please consider subscribing to my channel. Here is my channel. Now a couple of more things. All of the code that I am writing from now onwards, you will get that code in this repository. So before I upload this video, I will upload the code also, and I will give you all of the required link in the description of the video, correct. Is there anything else? Yes, one more thing. From this code, can you please try to modify this particular code to fetch a smallest palindromic substring which is not 1 in length, okay. Try to fetch a smallest palindromic substring which is not 1 in length. Let me know in comments if you were able to fetch it, and even if you were not able to fetch it, do let me know. In the next video I will do it for you. Okay, thank you very much for being here guys. I will see you again in the next videos. Till then, bye bye.